All right, so let's look at some of the equations or forms of a linear function. In section 1.3, we learned about slope-intercept form, and that's the y equals mx plus b. You want to use this form if you were given the slope, m, and the vertical or y-intercept, which we represent with the letter b. And if you're given those two things, you can just drop them right into the formula here and be done writing the equation. This form is the most useful form if you're being asked to graph a function. And the reason for that is that this b here is the y-intercept. So you know that that's going to be located here along the y-axis. And once you've plotted that point, then you can use the slope. So if the slope was 2, we'd go up 2 over 1, up 2 over 1, and that would give us a couple points, and that's enough to draw our line. So that slope-intercept form is really useful if you're being asked to graph a line. Right, let's add another one. This is the point slope form. And this has y minus y1 is equal to m times this, in parentheses, the quantity x minus x1. So you'd want to use this form if you were asked to find the equation of a line given the slope m and 1 point. And we'd represent that point with an x1 and a y1. And so you would just fill those in. You'd fill in the y1, the m, and the x1, and then you're done. So you don't need to simplify the point slope form once you've filled in the numbers. It's fine to leave this as y minus a number equals the rest of it. Okay? This is also the form you want to use if you're given 2 points. So maybe you're given the point 1, 1, and 3, 7. Okay, so if you're given that, you'll use those 2 points to find the slope. And remember that the slope is y2 minus y1 over x2 minus x1. So you can use those 2 points to get this. And then just pick one of the points. It doesn't matter which one. And you can plug it into this formula and you're done. Okay. This form, if you're going on to calculus, this is pretty much the only form we use in calculus. And that's because calculus gives us a really great technique for finding the instantaneous rate of change, which is going to be our slope of any function at a point. And it's really simple to do in calculus. And so we use this form all the time because you're given a point and then you can just use that process. All right, and then we have one last type here to look at. It's called the standard form. So this is ax plus by plus c is equal to 0. Okay, we won't use this form a whole lot in this class. You won't be given some information like a slope or something like that and asked to put it into a standard form. But what the standard form is really useful for is that you can use this if you know that this is the form for a line. A parabola would be ax squared plus bx plus cy plus d is equal to 0. That gives you a parabola. And so if you know the standard forms, you could just look at it and say, oh, that's going to be a line, that's going to be a circle, that's going to be an ellipse. Okay, so that's mostly what I find the standard form to be useful for. All right, so let's take a look at kind of using these. We're going to turn to this next page here. And we are going to find the slope and vertical intercept by rewriting this equation into slope-intercept form. Okay, so this one here is actually written, it looks like, in standard form. This one is not written in any form at all, but that's okay. So to find those, we're going to rewrite these into slope-intercept form. And the reason is because those are the two things they're asking us to find. So I get 5y is equal to negative 3x plus 20, which means y is negative 3/5 x plus 20 over 5. Right, so that 5 gets divided to both of those. So my slope, which is letter m, is negative 3/5. And my y-intercept, or my vertical intercept b, is 20 divided by 5, which is 4. All right, go ahead and pause the video, give this one a try, and then we'll come back and take a look at it together. Okay, so let's take a look at this. So I have a 5x plus 2 is equal to 3y. So I added that 3y to the other side. And I'm going to divide everything by 3. So I get 5/3 x plus 2/3 is equal to y. So my slope, m, is 5/3, and my y-intercept b is 2/3. All right,